This circuit is a full-bridge Pure Sine Wave Inverter designed with Arduino and IR2110 gate driver IC to convert 12V DC into 220V AC. It is a sophisticated inverter design because it uses a specialized high-side, low-side gate driver, IR2110, and an LC filter to produce a high-quality output. I will begin explaining the circuit by starting with the main DC power supply and then explaining the rest of the circuit by breaking down into 4 main stages to get AC output voltage. The DC power supply. The main DC power supply for the inverter comes from the 12-volt lead-acid battery. The IRF2110 gate driver, IRF3205 MOSFETs, and the transformer all receive 12-volt supply from this lead-acid battery. The PWM controller, which is Arduino, receives 5 volts using the LM7805 voltage regulator. The 7805 voltage regulator, the 7805U1 ensures the Arduino gets a clean 5 volts, isolating it from the heavy switching noise on the 12-volt rail. The capacitor bank, the capacitors C1, C3, C2 and C4 are decoupling capacitors. They provide a local reservoir of energy to prevent the battery voltage from dipping during every high current switch. Now I will explain the rest of the inverter circuit by breaking down into the 4 main functional stages. 1. The Arduino control stage. The Arduino Nano acts as the brain. It generates 31.25 kHz sinusoidal pulse width modulation signals. It sends high-speed PWM switching pulses to the IR2110 driver HIN pin 10 and LIN pin 12. By varying the width of these PWM pulses in a sinusoidal pattern, and after filtering the PWM signal, a 50 Hz AT signal is generated. The Arduino pins D11, D10, D9 and D3 are used to drive the HIN, high input pin 10 and low input pin 12 of the upper and lower IR2110 gate drivers respectively. Two, the IR2110 gate driver stage. Here we have used N-channel IRF3205 MOSFETs on the high side. Since the N-channel MOSFETs on the high side require a gate voltage higher than the source voltage from 12-volt battery to turn on, the IR2110 is essential because it has support for Bootstrap Circuit and specially designed to work with N-channel MOSFET on the high side. The Bootstrap Circuit. In the circuit, the diode D1, capacitor C11 on the top IR2110 gate driver IC, and diode D2, capacitor E12 connected to the bottom IR2110 IC form the bootstrap. Here is how it works. When the low side MOSFET is on, the capacitor charges to 12 volts. When the high side MOSFET needs to turn on, this capacitor lifts the gate voltage to roughly 22 to 24 volts and thus is able to turn the high side MOSFET. Protection resistors. The 1 kilo ohm resistors R1 to R4 protect the Arduino pins from transients, and the 22 ohm gate resistors R5 to R8 prevent oscillations during switching. Capacitors C5 and C7, C9 are decoupling capacitor for 5 volt VDD and 12 volt voltage VC respectively for the upper IR2110 IC, and capacitors C6 and C8, C10 are decoupling capacitor for the plus 5 volt and 12 volt pins of the lower IR2110 IC. 3. Power stage. The H-bridge consists of 4 IRF3205 N-channel MOSFETs, Q1 to Q4. The power MOSFETs. The 4 IRF3205 MOSFETs switch in pairs. The Q1 and Q4 MOSFETs turn on together to send current through the transformer in one direction. Then Q3 and Q2 MOSFETs turn on to reverse the current. This MOSFETs are switched alternatively on and off thousands of times per second. That is at the PWM frequency, which here is 31.25 kHz, and chops the 12-volt DC into an alternating AC signal. The 22 ohm gate resistors R5 to R8. Their role is in oscillation dampening and inrush control. First rule is preventing parasitic oscillation. The MOSFET gates have internal capacitance. Without the gate resistors, the trace inductance and gate capacitance form a high-frequency LC resonant circuit. This causes ringing, which can keep the MOSFET in the linear region or even destroy the gate oxide. The second rule is limiting peak current. When the IR2110 switches, it tries to deliver a massive gulp of current to the gate. The 22 ohm resistors limits this peak current to a level the IR2110 can safely handle. Typically 2 amps, protecting the driver's internal stages. the 1N4148 discharge diodes. The role of these diodes are in asymmetrical switching and dead time security. First, the fast off path. These are placed in parallel with the 22 ohm gate resistors with their cathode away from the MOSFET's gate. When turning on, current must go through the resistor. Slow. When turning off, the diode provides a short circuit path bypassing the resistor. Their second role is in preventing shoot-through. By making the MOSFET turn off faster than it turns on, a hardware-level safety margin is created. This ensures the top MOSFET is fully closed before the bottom one opens, preventing a direct short circuit across the 12-volt battery. The 10 ohm pull-down resistors. Their role is to create a defined logic state and static protection. First role is floating gate prevention. MOSFET gates are like high-impedance sponges. They can pick up static electricity or stray electromagnetic interference from the air. If the gate floats to just 2 volts or 3 volts, the MOSFET might partially turn on, overheat, and fail. Second role is fail-safe during startup. When the inverter is first powered on, the Arduino and IR2110 take a few milliseconds to initialize. During this blind moment, the 10 ohm pull-down resistors ensure the MOSFET gates are tied firmly to ground or the source pin, keeping the H-bridge safely locked in the off state. 4. Transformation and filtering. Step-up transformer TR1. This takes the high current 12-volt AC and steps it up to the 220-volt required for the load, in this case the bulb. LC filter L1 and C13. This is one of the most critical part for a pure sine wave. The 22 MHz inductor and 2.2 UFAF capacitor act as a low-pass filter. They strip away the high-frequency PWM noise, leading the smooth 50 Hz sine wave for the 220-volt bulb. I hope this video was useful in understanding the circuit components of an inverted circuit. In the next video, I will show, via simulation and animation, how the circuit works, showing you output voltage using AC voltmeter, the signal wave, and frequency spectrum of the output signal. Thanks for watching.